Oh my God! Lots of solar features to talk about today, and welcome to the Daily Space Weather, the primary feature of the Smash News Network, least busted name in news. By the way, we've got all kinds of other content as well on the channel, so make sure you check that out. And thanks for tuning in. Congratulations on realizing that the channel exists. This is the past 24 hours from SDO. Looking at ionized helium. Did you know that the sun makes more helium around solar maximum? Yeah, all those white areas are areas rich in ionized helium. It's 304 angstroms from Solar Dynamics Observatory. And let's add 193 angstroms to add some contrast to the solar filaments, of which there are lots. Likelihood of coronal mass ejections, nearly 100%. Likelihood of solar flares increasingly higher as this sunspot approaches the limb. And let's take a look at some of the features that you might find interesting. So first of all, we've got some crown prominence activity happening around the northern polar region. You can see that filament there. It's creating another solar polar vortex up there. And you can expect to see about 20 more months of this level of activity on the closest star. Here's the equatorial view. We cheated a little bit to the west because of all those prominences hanging out there over the western equatorial limb. Huge sunspot setting there. We'll show close-ups of that a little bit later as well. Massive filaments in the southern hemisphere and a small crown prominence down there at the South Pole as well. Will it turn into a solar polar vortex? Let us know in the comments what you think. The most active region is, in terms of solar flaring, has been down there in the southeast, below the Earth scale there. That relatively new sunspot has produced a couple of M-class flares, which we will also show you in shockingly dense detail. And there is the northeastern limb. You can see a coronal hole there. There's a bit of a magnetic tug-of-war going on as well. We'll talk about that and lots more on today's video. Once again, thanks for tuning in. Let's take a look at sunspots from the SDO. There's the SDO continuum, and we've got significant sunspot growth there in the southeastern limb. We've got two very likely places to see large flares. Once again, in the southeastern limb. That's the second most likely place. And as this sunspot group approaches the limb, it becomes the most likely place to produce an X-class solar flare. Here is the colorized magnetogram. These depict yesterday plus today, so July 1st and July 2nd to date. Coming at you a little late today because, well, we slept in. So this Sunday edition also features volcano coverage. Let's see what's erupting around Crescent Earth. Shivaluch now back on the list here as it explodes and produces a 12,000-foot ash plume over Kamchatka. It's a flight level 120, flight level 070 over Subinosejima. Mount Mayan producing a 10,000-foot ash plume over Luzon Island, Philippines. And now Merapi appearing back on the list as it's extruding some new real estate there over onto central Java, Indonesia. Yeah, also some phoenix clouds there as the dust lifts. So I'll check it out. We got a video here of Merapi. Let's make sure we've got the sound muted. There you go. Block and ash flow happening there as extrusive lava rolls down the banks of Merapi. Dacono also exploding, flight level 070. 7,000-foot ash plume there. 21,000-foot ash plume over central Mexico from Popocatépetl. It's a flight level 210. Not sure about Fuego. It could be erupting. Don't assume it's not. 23,000-foot ash plume from Sangay in Ecuador. Volcanic ash not detected from Revenador. Sabancaya exploding in Peru, producing a flight level 220. 22,000-foot ash plume over Peru from Sabancaya. 18,000-foot ash plume over Peru from Ubinas. And now Pitan de la Fournaise is back on the list. That's producing some effusive eruptive activity as well. Let's move on to earthquakes. There was one significant earthquake in the past 24 hours. There's the past 90 days. To put earthquakes in context for you, the largest quake of the past 24 occurred northwest of Niafu Island, probably felt by just about nobody. It was large, but it was also at depth. North of Tonga was the location of that. It was a 6.9 magnitude quake, but it was at 134 kilometers estimated depth, so we didn't even send out emails about that one. It is just about 0% likely to have produced a tsunami. Let's check the rest of the list for the past 24 hours. We will cite quakes of a 5 magnitude or greater. Little quake swarm there in the Caribbean, some quakes in California, Alaska, and Oceania. These are the quakes of a 5 magnitude or higher. This 5.0 starts out the list. That occurred late last night at 22:21 Universal Time. 5.0 near Tonga. Also, there was a 5.0 at Peru there on the west coast of South America. That was at 1:25 this morning. Also a 5.6 at Tonga. That was at 2:41 this morning, Universal Time. That 6.9 this morning occurred at 10:27 Universal Time. It was at a depth of 225 kilometers, and let's get back to space. Yeah, space. It's where it's at. Here are the past 24 hours in SDO 171 angstroms. And my, have we got some fresh imagery for you in that wavelength. It's ionized iron from the Solar Dynamics Observatory. And here is the spectacularly huge sunspot setting in the northwest. Huge filaments there around it. Again, the likelihood of it producing an X-class solar flare. The likelihood is rising. So we'll be keeping an eye on that. And when I say ion, pardon the pun. Yowzers. That is some sweet imagery indeed. And if you think it's CGI, you're correct. Here's the southeastern limb. It is CGI because these wavelengths are not visible to the human eye or from ground level. You got to be in space and have a UV sensing device, like the Solar Dynamics Observatory's AIA instrument. Check out the filament there by the Earth scale. Some plasma jets happening there. And that was the region that produced the M-class flares for the past 24 hours. The time frame depicted in that video. We'll get to coronal holes and so forth next. Before we do that, let's take a look at some other stats. The 10.7 centimeter radio flux is now at 166 solar flux units. So if you're wondering what a solar flux unit is, it would be 10,000 Janskys of radio flux density. Janskys are just a measure of radiation traveling through space. So the 10.7 is super important. It's the proportional data set that we have to sunspot number, as you can see on that graph right there. You see the black line, you see the red line, you see how similar they are in terms of their peaks and troughs. The black line is the radio flux, the red line is the sunspot number, the pink line is the 30-day the 30-day wolf number, the 30-day average of sunspots. And this is going to be updated soon here. This is going to be back up at about 180 for the sunspot number. That's the red line. And let's move to the Space Weather Enthusiast dashboard. So we saw a weak CME impact yesterday as forecast. It was basically just kind of moving past Earth there. It barely even registered anything. It was as glancing of a glancing blow as you could possibly get. It was just this side of nothing showing up on the solar wind data. Anyway, that's NOAA's forecast. No space weather storms or CME impacts, coronal hole impacts, etc. expected in the next 3 days by NOAA. Next, Earth's magnetic moment from space. We show the past 4 hours daily on the channel. It's the Geospace Magnetosphere movie. It depicts magnetohydrodynamic pressure. And at the moment, the plasma is trying to reach static equilibrium, which is why the pressure is on the magnetotail side. It's not because Nibiru, Planet X, Nemesis, or any other non-existent features of the solar system are on the non-sun side of the planet. Keep in mind, folks, if there was a mysterious star or planet floating around in the solar system, people would see it, even if it was pitch black, emitting no light because of obscuration. It would get in the way of other stars, and then it would be noticed, the same way asteroids are detected. That's the past 4 hours of Earth's magnetic moment from space. And here are the past 4 hours of Earth's magnetic moment from the ground. This depicts magnetic flux density at the ground level. It's showing you the location of Earth's magnetic poles in some ways. It'll also show you the most likely places to see the aurora. Pipeline, railway, and power grid induction, etc. The past 4 hours of Earth's magnetic moment from the ground. Geospace delta B changes to Earth's B field. Next, the planetary K index is at 2. KP2 is the current geomagnetically calm situation. KP2. And let's move to the real-time solar wind. So here you can see these variations happening in the real-time solar wind. This is the CME brushing past Earth, barely even creating a signal there as the density fluctuates between 10 and 3 protons per cubic centimeter. Keep in mind the real-time solar wind is measured at Lagrangian point 1, a million miles away from Earth, well outside of Earth's magnetosphere. It's like about 4 lunar distances away. And it's the gravitational equilibrium point orbited by the ACE and Discover spacecraft. At the moment, it's just the Discover spacecraft. Current conditions are showing up as about 3 protons per cubic centimeter for the solar wind density. Solar wind speed here, 442 kilometers per second. Pretty unremarkable, just like that brushing past CME glancing blow thing that occurred yesterday. GOES magnetometer here looking pretty smooth. No major surprises there since the CME impact was so weak. I think I gave it a 30% chance of doing anything. And I think that was a pretty accurate forecast. What do you think? Let us know in the comments. Next, one of the most important data sets for forecasting. If you want to see something with predictive value, check it out. This is the top view ecliptic plane field plot, part of the National Solar Observatory data. So this is super important. And I've found through years of observation that this is actually one of the most important forecasting tools that you have. We've forecasted again and again incoming activity, solar cycle progression, and so on using only that. And the important feature to note here once again is this coronal hole, which you can see disappearing and then reappearing as it snaps back at the north heliographic polar region. There it goes, it's back again. And it actually grows and then it shrinks again. So again, you can expect a long time of this level of solar activity. That's the top view ecliptic plane field plot. If you want to follow it yourself, if you understand the correlational aspects of this, it'll help you forecast as we empower our viewers to be able to forecast just like we do. Anyway, here's our line of sight field plot. You can see the sun's B field there all fanned out, as Earth is kind of right in the middle of a North Pole current sheet. As you can see here, there's the last image, kind of right in the middle of a North Pole current sheet there. And so no surprise that the B field is all puffed out like that. That's what happens when you're in the North Magnetic Pole. Welcome to the North Pole, folks. The North Heliographic Pole. You're in it. And of course, one of the most important features of solar cycle progression is coronal holes. And there they are, a bunch of North Pole ones. And we talked about a magnetic tug-of-war going on. You'll see some South Pole coronal holes briefly opening up here. And that's a little bit of indecision. That's magnetic cancellation happening right there, and that is weakening those magnetic fields in the corona. That said, let's move on to sunspots right after we show coronal holes from SDO 211 angstroms. So all of these well-defined coronal holes are of North Pole orientation. Some quite well-defined ones there in both the northeast and in the southeast. We may see a minor intensification of the solar wind from this one. although it will be likely short-lived if it does produce any geomagnetic effects. We'll keep you posted on the channel on our daily space weather videos. So let's go to Sunspots next. Oh my God. Dear God. All right, there we go. There are sunspots. And let's see, it looks like there's a group up here in the northeast that hasn't been named yet, so at least one more named sunspot group. Check out the likelihood of solar flares. Incredibly high. So, once again, we still do have a likelihood of a large solar flare from down here, and an increasingly high likelihood of an even larger solar flare up there in the northwest. Here come sunspots from SDO's continuum. Yowzers. That is, once again, a lot of sunspots, and you can only expect this to increase for over half a year, folks. So it's going to be an exciting 20 months, as you can expect to see these levels of activity or higher for the next about 10. Let's show some extreme close-ups. So the group that's been producing the M-class flares is that group closest to the Earth scale there. You can see some growth happening there. A little bit of umbral consolidation occurring. A little bit of growth in the trailing umbrae. Thank goodness for the SDO. It's my favorite telescope. And here is this massive sunspot group in the northwest. And again, as that gets closer and closer to the limb, its likelihood of producing an X-class flare keeps going up. We're stoked about it. What about you? Let us know in the comments. No solar energetic particle events for a long time. Let's get to that next. And by the way, if you think that we're already at solar maximum, or you think that the sun is in a grand solar minimum, stop sucking so hard at math. Maybe do the math. You are lost in space if you think we are in a grand solar minimum. It couldn't be farther from the case. Stop trying to redefine the term. Some of us aren't even sure if the term grand solar minimum refers to anything that's ever occurred in reality. But in any case, this situation is definitely not a grand solar minimum. It's just pretty sad as, well, it's going to be an interesting, once again, an interesting about 10 months here, as many cultists, probably half of the cultists are going to leave the grand solar minimum cult. And the other half will double, quadruple, and octuple down on their nonsense, becoming increasingly isolated and believing increasingly ridiculous nonsense to continue to prop up an utterly debunked theory. By the way, it's an 8-year-old theory, and it has not been reflecting reality for the last about 3 years. So do the math, and please don't suck at it. Please do visit our links, and perhaps pick up this handsome design to tell all your friends and foes who are lost in space to try not to suck at math and show your work. Show your work when you say do the math. 8 equals capital D. Did you know I used to be a computer science / math major? It's true. It's true. No spikes in the proton flux here worth mentioning. Just a tiny little spike there, just maybe a few minutes ago. Barely worth even talking about. Ghost proton flux here remaining flatline. No solar energetic particle events of note for a long time. As far as solar flares go, there were 2 M-class events. Let's bring up the 1 day here to get a little bit closer idea of when they occurred. So late last night there was an M1.11. That was at about 22:22 Universal Time. And then this morning, around 2:36, there was an M1.9. Also, the background level of X-ray flux has come up. The background level here probably something like a C2. And let's C2 what's going on with Close-ups. Yeah, some more fantastic imagery here from SDO. So here is SDO 94 plus 131 angstroms. Expect to see large flares up here and secondarily down here. So that's the group that's been producing the M-class flares. You can see both of them in that imagery. And here's a full disk equatorial zoom for you. And moving right along on our Sunday edition, next we've got your sky chart. So that's what's going on overhead here in the Lehigh Valley, Pennsylvania. If you're planning on a cycling vacation, why not come join us and come ride Lehigh Valley, Pennsylvania? That's the current situation. And fun fact, the difference between a pro cyclist and a non-pro cyclist is that pro cyclists take vacations from cycling. The rest of folks take vacations to go cycling. Understand? Anyway, that's what's going on if you're viewing the night sky. Great view of Mars and Venus very close together. Continue on. Mars just north of the ecliptic, Venus right on the ecliptic plane if you're viewing the sky after dusk. By the way, if you're planning on going to space, make sure you check out our Amazon shop. Check out the spaceware section. If you want your own radiation-reflecting hat, we've got it. Next, your solar system forecast. This is where heavenly bodies are. I mean, besides the heavenly bodies that are viewing this video, this is where those heavenly bodies are located. Let's do a one-week forecast here from theplanetstoday.com. That's where things will be in a week on July 9th. And let's move on to coronal mass ejections. There have been some. They do not appear to be earthly directed based on the coronagraph imagery we have. That is 103 frames from yesterday from George Mason University.